Hi class, so today's lesson is going to be about conditional probability, which is calculating the probability of an event if you're given some other information about that situation, all right? Let's do this in the context of a game. So let's say in this game there's two chips, blue chips and pink chips, and you get to randomly draw a chip out, and if you get a pink one, you win, all right? There's two containers, a cup and a box. So the cup has one pink chip and one blue chip inside. The box has one pink chip and 4 blue chips inside. How this game works is you will flip a coin randomly 50-50, and that will determine whether you get to pick out of the cup or the box. And then from there, you get to pick a chip out. If you get a blue chip, then you lose. And if you get a pink chip, then you win, okay? And so we can examine these probabilities, and what you might want to do is actually pause this video right now and create an area model or a tree diagram for this situation. Okay, so now let's examine the situation's probabilities. If we just think about it initially, we've got the cup, we've got the box, there's a 50-50 chance of picking either. One of the probabilities we might want to look at is what's the probability that we picked a cup? What's the probability that we picked a box? That's pretty straightforward because it's a coin flip. That's just going to be 50%. We can also calculate what's the probability of getting a pink chip or winning this game in general. And your area model and your tree diagram will help with that. But now let's throw in conditional probability. We want to know, let's say you know that you got a pink chip. You know that you won the game. What's the probability that it came from a cup? What's the probability that you won from picking out of the box? All right, so that's what these conditional probabilities look like. You might have, well, let's think. If you know that you won the game, but you don't know whether you picked out of a cup or a box, do you think it's more likely that you picked from the cup? Do you think it's less likely that you picked from the cup? Or do you think it's the same? It started at 50% and it's going to stay 50%. What does your intuition tell you? Now, if you won and you got a pink chip, but you don't know whether it came from the cup or the box, what's it more likely to have come from? Well, you're more likely to win from the cup because there it's a 50-50% chance. From the box, in order to win, that's a 20% chance of winning. So it's much less likely that you won if you drew out of the box. So it turns out this conditional probability is not 50%. The probability that you picked out of a cup, if you know that you picked a pink chip, is actually going to be greater than 50%. And so how can we calculate that probability? Let's look at an area model and then a tree diagram. So here's the area model, cup and box. From a box, it's a 20% chance of getting the pink chip. From the cup, it's a 50-50% chance. So if we want to know the probability that we picked out a pink chip or that we won, we'll take this 10% and this 25%. We'll add those probabilities, and our probability of getting a pink chip just overall in general is 35%, okay? And because of that, we can kind of just ignore the rest of the sample space, especially when we start looking at the conditional probability. What's the probability that we picked out of a cup, knowing that we got a pink chip? Well, if we know we got a pink chip, we can ignore the rest of the sample space and just focus on this 35% area right here. And because that's our given and that's known, that ends up being our whole, essentially, that we're going to divide by. That ends up being like our 100% because we know that's what happened, nothing else happened. So we're going to focus on this 35%. That's what we'll divide by. Well, what's the probability that we got picked out of a cup, knowing that it was a pink chip that we got? Well, that's where we're going to focus on this section right here. Well, we know we got a pink chip. We want to know what the probability it came from a cup. We'll take our 25%, divide by that 35%. And that gets us 5/7 or 71%. And that fits our intuition that it should be more likely that we got from a cup if we know that we did indeed get a pink chip. Now, this is where sometimes students make mistakes. Where did we get that 25%? Well, that's from picking out of a cup and getting a pink chip. And sometimes students mistakenly just use the cup probability, right? The probability of getting a cup is 50%, but if you put that as the numerator, wouldn't your resultant probability be more than 100%? Would that make sense? No. So you wouldn't just use the 50%. Because you know it's given that we had a pink chip, we're going to use this 25%. And really, so that's the probability of both happening. The probability that we got a cup and a pink chip is 25%. That ends up being our numerator, okay? Let's look at it from a tree diagram perspective. The probability of a pink chip, again, is 7 out of 20. That's 2 out of 20 plus 5 out of 20. And what we'll do now is, let's look at this conditional probability. What's the probability that we picked out of a box, given that we know we got a pink chip? So last time it was 71%. This should be the converse. This should be 29%, right? So let's check and see if that works. If we know we got a pink chip, we can reduce our sample space and just focus on the branches where we end up getting a pink chip. That's our 7 out of 20. We know that that's our denominator. We're going to divide by that because that is the whole situation. 7 out of 20, that's what happened. Nothing else happened, so that's our whole. And then the probability that it was a box that we got the pink chip out of is 2 out of 20. That ends up being our numerator. When we divide those, we get 2/7, or that 29%, which makes sense with the previous context. All right, hope this helps you understand conditional probability. If you have further questions, feel free to contact me or come into office hours.